Hello, our most valued student. My name is Confident and welcome to the NCV level 2. And in this series of videos that I'll be bringing in, I'm going to be preparing you for your final exams. So if you're preparing to write your final exams for your level 2 mathematics, I will prepare you for your first paper as well as your second paper. So this is one of the papers I'm going to use, and this is, as you can see, mathematics first paper, level 2. It was written in 2022, so this is more like what they call it, the rewrite for those who wrote in the previous year. So now I'm going to go straight. You guys know your paper, you have gone through your paper. So for those who are new, who will be writing for the first time, these are the instructions, but one thing that I want us to draw close to is the rounding off. We're going to leave our answers to 3 decimal places. All right, it's very important to follow these instructions. So let's look at the first question. So now, by the way, this is not a full video covering everything. So you see there is question 1 here. It goes on to question 2. This paper goes on to question 3. It goes on to question 4. It ends in question 4. So this is out of what? It's out of 100 marks, as you can see. So this is a full paper. And then what I'm interested in is this formula sheet. You see? This is what I'm interested in because we're going to use quite a lot of it. So let us get started with this question paper. So while I'm going to be looking at question number 1, and I will also be going through this formula sheet here that I just brought close. So we're going to be using that wherever it fits in. First one says convert the following decimal in the form a over b, where a, b is an element of z real numbers, but b must not be equal to 0. But it says what? Without a calculator. Express the answers in simplest form. So they give you the first one, 1, 1, 2, and 2 is recurring in 3 marks. So you know, you need to play around this kind of a question. They always bring it as usually the first question. So what you have, you can say, let our x be equal to, let me write it properly, let our x be equal to this 1, 1, 2. It says recurring, so this number is like this. You know, this is what you're having. Now the aim is to multiply this number. You can try, remember, as I say, it depends how you want to approach it. You can do a simple trial by error, but now you want to have it in such a way that when you multiply this number, okay, if I can take the same number here, this x, let me duplicate it, and if I multiply it now, if I multiply it either by, can be a 10, can be 100, it can be 1,000, it depends. So you look at how you're going to move, you move the 0. So if you're going to say, okay, from here, 1, 1, I want to move it, the comma to be there. So it means you multiply by 10. You see, it's 1 comma. If you want to move the comma to be there, it means you multiply by what? By 100. Like that. So you're going to use it in such a way that when you subtract, so okay, by the way, when you multiply by 100, it will be also 100 this side. Just be careful of that. Are you with me? So let us start by saying we want to multiply it by 10 as an example. So when you multiply by 10, here we'll have what? 10x. So when I write it, it will be 10x is equal to, so I will have 1, remember the comma is there now, 11, 2, 2, 2, 2, 2. So you can continue this 2 forever. And then when I bring down my x, remember, it will be x is equal to 1 comma, see, 1, 2, 2, 2, 2, 2. So that's where now we have to now compare. The aim was when you are subtracting on this other side here, the aim was to have all the numbers on this other side, and in here you wanted to have the 2, 2, 2, 2, and even here the 2, 2, 2, 2. That is the aim. That's what makes it better. So when you do like this, you can see that instead I have got that one, which is making it difficult for me. So what I can do, I can continue this and say, okay, I multiplied it by 10. How about I take this number now, this number, duplicate it, I further multiply it and say, okay, what are you going to multiply it by? If I can multiply this one by 10, let's change it here to say by another 10. When you're multiplying this by 10, so 10 times 10, this will become now what? 100, you see now. And then here I move the comma there. Remember I told you when you're multiplying, it's about moving this comma. So instead of 11, you will have 112. So this number will become 100x. See now, pay attention now, is equal to 1, 1, 2, comma, 2, 2, 2, 2, 2. And remember this one is continuing. And then let me bring now not my x, let me bring this 10x down there. So what will it be? It will be 10x is equal to, and remember it's 11 comma, look now, 2, 2, 2, 2, 2. You see that? Now if I bring back that concept to say when you cut here, you see that I've got only 2, 2, 2, 2 going this direction, 2, 2, 2, 2 going this direction. So that was the aim of this whole part. That's what you practice yourself whenever you're doing this kind of questions. So when you have done it like this, that's the solution now. You subtract the bigger one from the smaller number. You subtract here. So you're going to say 100x minus 10x on the left hand side is equal to, when you subtract here, look at this, you see 2 minus 2, 0. All this will become 0, 0, 0, 0. So what are you subtracting actually? You are subtracting 1, 1, 2 minus 11. Do you see what we're doing? So what is 100 minus 10? It's 90x is equal to, then here 112 minus 11, it will be 101. And you know guys, when you're solving for x, you want to remain with x here. So what is it? You need to get rid of this 90, and x here is multiplying, remember. So the opposite of multiplication is you divide. So divide by 90, you divide by 90 on both sides. So that's how you remain with your x. So what is our x? X is equal to 101 over 90. And then they told us we need to leave it in the form of what? Of a over b. Remember this, a over b. So this is the a part that they are looking for, the 101. So that's your kind of your a over, and then our b is that, you see. So this is the answer, 101 over 90. Alright, so that was that. If I can then move on to the next one, I need to be a little bit quick, but it's fine. Then this one, 0,048. You are supposed to simplify it in a over b. This one is not difficult. It's 0,048. Now you ask yourself, if I want to make this a whole number, how many decimals must it move? Look at this. It must move 1, 2, 3. So from here, you move 1, 2, 3 decimal places. I'll call it dp. So to move 3 decimal places means you are going to move how many zeros? You need 3 zeros. 1, 2, 3. Meaning you need to multiply by 1,000. So what you're going to do, you are going to say 0,048 times what? Times 1,000. what are you going to have? You are going to have, now when you multiply by 1000, then don't forget, you are going to have 48. Remember, it's the number, but you are dividing that number by that 1000 that you multiplied with. Alright, and then from there you simplify. Remember, they say don't use a calculator, so you find ways of simplifying, whatever way that you think you can simplify this. One way you can do to make things easier, this is 48. Maybe we can say here, yeah, it's fine. You look at any way you can do. If you're comfortable dividing by 2, I think you can do by 2. You can divide by 4. You can divide by any number. Let me use 4. 4 into 48, it's 1 and 2. 4 into 10, it's 2. Remember 2. 4 into 20, it's 50. So I have got 12 over 250 is at the end. I think it can continue. 2 into 12, it's 6. So I've got 6 over 2 into this, it's 125. 6 over 125. And then with this one, guys, you just have to use a calculator to test this. Okay, you could have done that earlier, by bringing in the what? You bring in the calculator already, and then you say 0,048 equal to, you see, 6 there, 6 over 125. But however you do it, it's okay. Now move on. Convert. We're now 1.2 here. It says convert to 1 and 4 over 25 as a decimal number without using a calculator. There it is. It says we must not use a calculator also here. So what you can do, 1, what is it? 1 and what? It's a mixed number, 4 over 25. Say convert it as a decimal. Now what you need to know, when it's written like this, it is the same as saying 1 plus that fraction, which is 4 over what? Over 25. Okay, so your aim is to now convert this fraction. How do you convert it? It's up to you to convert this as a what? As a decimal. So which is equal to 1 plus, you can try to work in thousands. For example, multiply the top and the bottom here by 4 by 4. You can choose to do that. And then why am I doing it? You'll see 4 times 4, it will be same as saying 4 times 4 is 16 over 25 times 4. You see, it's 100. You see, it's easy to divide 100 up there. So we are going to say 100 into 16, 0, 100, you put a 0 there. 100 into 160, it's 16. You see that? That was the easier one. Or alternatively, you could have said 25 into 4, 0, 25 into 40, it goes 1. And then you're going to say, remember what? 40 minus 25, you're going to say 15. And then put a 0, 25 into 150, you get 6. So whatever you do, it is going to be fine, but show that you never use a calculator, which is 1 pi plus 0,16, which is 1,16. But obviously, guys, be quick to test this. Your calculator then must be so handy. You mustn't just trust. Don't just lose your answer here. 1,16 equals to this, and then you press shift that. You see, on SD it will give you that. Alright, now I think most of you will be saying, look, move on to the algebra where we are struggling. This is fine. Let's do then the algebra. Simplify the following using laws of exponents. Leave the answer with positive exponents and insert form where applicable. There we go. Let's start this. 1.3.1. What are they saying? They're saying you're given 27 p to the power of negative 3 q to the power of negative 2 over 3 to the power of negative 4, p to the power of 2, and q to the power of negative 3. Okay, this is what you have. Now, whenever you're using exponents, as I told you, these are the laws that they brought. So they are simple laws that I'm going to use. For example, I'm going to take everything. Let me do this to make things easier for me. Okay, there are just a few things that you first out do. 27, you say don't work with big numbers. You ask yourself, 27. You say 27 is 3 to the power of what? It's 3 to the power of 3, you see? But what do you do if you have a calculator that is latest? You're going to say 27 equal to, then you press shift, then there is this button here. It will say FACT. If you press it, it will give you 3 to the power of 3. So already on top, what you're going to have 3 to the power of 3. Then this is saying times p to the power of negative 3 times q to the power of negative 2. Now at the bottom, I want you to take note here. And b, at the bottom, I want to take it to the top. I want to take it, everything here, I want to go where? To the top. And I'm going to use which law? I'll show you the law that I'm going to use. It is law number 6. Is it law number 6? No, yeah, it's law number 6 that I want to use, but it's put in different way. It's put in different way, but it's the one. You see, the way they've put law number 6, let me write it a to the power negative 1. Let me write it here. They brought it like this to say a to the power negative n is equal to 1 over a to the power of n. This is how they've written it. Are you with me? Now let me write it from here going this direction. 1 over a to the power a to the power of n is equal to a to the power of negative n. I'm just going from right to left. You see that? But this is 1 over. The good part is everything here is also at the bottom like that. I think that it's at the bottom. So now, which means when it goes to the top, it changes from positive n to negative n. Look at it, positive, negative. Meaning, you must know, the same law says, if you're given 1 over a to the power negative n now, you see, is equal to a to the power what? From negative to positive. Look at it. That's how that, you don't put that positive, but that's what it means. So that's what we're going to apply the concept here. So meaning, if I continue here, it says over. Now 3 to the power negative 4 here, 3 to the power, remember at the end, this is at the bottom. This is at the bottom. It's like I've got 1 over 3 to the power negative 4. Why? Because there is this division line. You see that? So when it goes to the top, what it will be? It will be 3 to the power from negative 4 to positive 4. What about p to the 1 over p? Not p. 1 over p squared. Now you can tell me quickly. It will be p to the power of what? Negative 2. Same thing with q. So let's write it. So now, when I write this, remember I no longer have this. I said I'm going to take everything to the top. Let me bring it down. So when I'm writing it, it will be like this. It will be times, I'll use a different one. The ones that are coming in times 3 to the power negative 4. You just interchange the sign. It's 3 to the power 4 times p becomes what? Negative 2 times q becomes what? Positive 3. You see, you interchange signs because of this division line. And we're using what? This rule. Alright, then from there we're going to use the first rule. This is where we are now. When we multiply, same base, when you multiply, what you do? you look at those that are the same, you add them up. So here you also collect like terms. Look at the first ones. There it is. You look at 3 and 3. You bring them together. So you have 3 to the power of 3 times 3 to the power of 4 times p to the power of negative 3. Where is another p? There is another p. You see? And then you're going to say times p to the power negative 2 times q to the power negative 2. There is the q. Where is the other one? There it is. Are you seeing this? Times q to the power of 3. Then you are using that law where you are adding. So 3 there, it will be 3 to the power of 3 plus 3. 3 plus 4 times p to the power negative 3 plus minus 2 times p to the power of negative 2 plus 3. We are adding. Okay, equal to 3 to the power 3 plus 4. We are adding. It's 12. It's 7. It's 7. Please, you're not multiplying, you're adding. 3 plus 4 is 7. Minus 3 plus minus 2, it's p to the power of negative 5. Use a calculator though. You can drop those times now. Q to the power minus 2 plus 3, it's 1. So this is what you're having. You can, but please, here, use your calculator. Just use your calculator here, here, and here. And then that becomes your answer. Alright. So that is that. And that was the question that we're working on here. Okay. So let's look at the next one, 1.3.2. So with this 1.3.2, it says I have 4ab, right, and times 2 bracket ab squared over ab times a squared b cubed. And then still the same thing, use the laws of exponents, leave answers with positive exponents, and in set form where applicable. I think I didn't do right thing there. Positive exponents, I was supposed to, in the previous one I didn't finish it up there, positive exponents, but I'll do this one here. Alright, so let's look at this. When they say leave your answer with positive exponents, same thing guys, nothing changes. You just have to apply the laws of exponents. Now whatever you don't see, let me make it big. When whatever you don't see, it means there is a hidden 1 here. A means there is a 1, B there is a 1, just know that. And when it's like that, it means this 2 is multiplying this. And remember I told you about these laws of exponents. We are using law number 3. It's a mn with a bracket. It's m times n. You see that? That is the first part. And then I told you also, you can take, okay, before we take everything to the, let's do that. We're gonna take everything to the top. Now I told you there is a hidden 1. There is a hidden 1. And you know when you're taking it to the top, the signs change. Secondly, you need to deal with this 4. You know what is 4? 4 is 2 squared. You see that? So we can write this straight away to say 4 there, it's 2 squared times a to the power 1 times b to the power 1. When you don't see any power, it's a hidden 1. And then times, you see there is a 2 there, it means to the power 1 times, okay, let me take this down because it's gonna be long, but that's the best way I advise. Okay, there are many ways of approach, by the way. Now there, remember we are saying a to the power 1 times 2 is gonna be times a to the power of 2, because 1 times 2 is 2, and here times b to the power of 2. Now looking at the one that went up times here, now they're going up, a to the power 1, I told you from the previous one, it becomes a to the power negative 1 times b to the power negative 1 times a to the power negative 2 times b to the power of negative 3. You just do that. And then equal to, then you simplify. Take 2 there and 2. You add them. 2 to the power of 2, because you're multiplying, you add 2 plus 1. And then you can still multiply since it's not done, times a. Look at it now. Look at all the a. 1. You must mark it. You see the way I do it, so that you don't lose out anything. So what you do there, every power you add, there is 1 plus 2 minus 1, or plus minus 1, it's fine. You do that, plus minus 1, because you are adding, and plus minus 2. But it's also fine to say 1 plus 2 minus 1 minus 2. Okay, and then you continue times. You focus on b now. There is my b, there is my b, there is my b, there is my b. So times b, which is 1 plus 2 plus, okay, I told you it's still the same as doing this, minus 1 minus 3 is still the same. Okay, it's up to you how you want to do it. And then you have to use a calculator now, which is 2 to the power 2 plus 1 is 3. Please use a calculator here, and then you can forget now about that times. And then here 1 plus 2 is 3, minus 1 minus 2 is 3. If you use your calculator here, it will give you 0. And then b, now 1 plus 2 is 3. Actually this 1 minus 1 can cancel. Now 2 minus 3 is minus 1. Alright, and then at the end you're gonna have that to say 2 to the power of 3. Now if you go again to the laws of exponents, there is this law number 7. Any number to the power of 0 is equal to what? 1. And then remember this law again, a to the power negative 1 is 1 over a to the power 1 when you're changing from negative exponent to positive exponent. That's why here this becomes here this is a 1, so it will drop off. So now b, that's when you use that to say a to the power negative n is 1 over a to the n. So meaning b to the power negative 1 is 1 over b. So here it will be 2 over 3 over b. That's what they mean when they say leave your answer with positive exponents. Right. Now simplify the following using set laws, showing all your steps. Alright, I think I need to bring it a little bit small. Simplify the following what? Showing your steps, the sets. These are sets. It's also not that complicated. Look at this. I've got square root of 20 plus 6 square root of 80 minus square root of 125 over square root of 5. Now I want to give you a hint. Most of the time they will give you something like this that looks complicated, but what you need to watch out for is what's the common denominator here. You take a calculator, you will see it coming out. Look at this. If I say square root of 20, you see square root of 5, there is square root of 5. Square root of 20 is 2 root 5. So you need to know, remember you mustn't use a calculator, but you must know how they got 2 root 5. 2 here is 2 squared, which is 4. So it's 4 times 5, which is that 20. What about the square root of 80? You say square root of 80 equal to, there again 5. You see 4 root 5. So you say 4 is what? 4 squared. It's 16 times 5. Square root of 125 equal to 5 root 5. But what is 5 squared? It's 5 root 5, meaning 25 times 5. Don't forget what we're just doing. So what we have here, you're gonna have square root of this. Okay, let me write the answers that the calculator was giving, and then I will fill up this, because you can use that and come and fill up this side. So for now, let's write the answer. On square root of 20, it gave us this equal to, it gave us 2 root 5. Check with the calculator. It was 2 root 5 plus 6. Now when it's like that, put a bracket. Square root of 80, what did it give us? Just for control. Okay, let me just check again. Square root of 20 was that, and then square root of 80 was 4 root 5. Square root of 125 was 5 root 5. So this one was 4 root 5 minus 5 root 5. See? Over square root of 5. Now what did the question say? The question says simplify the following showing the steps, meaning avoid using the calculator. If you just move from here like this, they will penalize your marks. No, they want the step in the center. And what is the step? You ask yourself, what is 4? 4 there, you say square root of that 2 there is 2 squared, which is 4 times 5, plus 6 bracket, that 80 there, 4 squared, it's square root of 16 times 5. Remember that. Minus, even here 5 squared, it's minus square root of what? 25. That's where 5 came from. Times 5. You see? Over square root of 5. They wanted this step. Always remember this, you square it, you square it, you square it, but put it under a square root. I think you see what I did. Okay, then from there you are allowed to use this, and I showed you that there is always something common denominator. Square root 5, square root 5, square root 5. So what you do is you take it out, is equal to square root of 5. What is going to remain? Here 2 is going to remain, plus here 6 and 4, but they are multiplying. It will be 6, 4, minus here it's 5 over square root 5, which is equal to, that's how the square root goes, you see. So what you're left with is 2 plus 6 times 4, which is 24, minus 5. So what you're simply having, you can use a calculator there, which is 24 plus this is 26, minus 5, which is 21. That's the answer. And you can now find it finally. It's easy to just also cross-check your answer, you see. Don't just leave it out. Take a calculator and just simplify this. And say if I'm given square root of 20, play forward, plus 6, square root of 80, play forward, minus square root of 125, and then over square root of 5. See, there, 21. Then check it, find that it was the answer that we got. Alright, so that was that. And then let's go to 1.5. I think I'm gonna end up here. Then we continue 1, 6, 1, 7, 1, 8 because of time. So simplify the following expression by rationalizing the denominator without the use of a calculator showing all the steps. Rationalization. Come here, it's also not complicated. It's 4 over 3 minus square root of 5. How do you rationalize? When they talk about rationalization, you know what they mean? They are saying times. This is how you rationalize. The denominator is the most important one. So you're going to multiply by the denominator is the most important. So you're going to multiply by the denominator, but you interchange the sign. So it will be 3 plus square root of 5. You just change that. Even on top, 3 plus square root of 5. You see, that's all that changes. Then you continue now, equal to 4 multiplied by 3 plus square root of 5 over, and then here 3 minus square root of 5, and then here 3 plus square root of 5. And then when you're multiplying, remember this is expansion, this times this and this times this. So what we have, 3 times 4, it's 12, minus 4 square root 5. That's what you're having. Over. Then here, same thing, expansion please. 3 times 3, 3 times that. And then the other one, FOIL method. This times this, this times this. It's a difference of 2 squares. In a way, if you know it, you can avoid others. But 3 times 3, it's 9. 3 times that, which is plus 3 square root of 5. And then minus square root of 5 times 3, which is minus 3 square root of 5. You need to know this part. And then minus square root of 5 times square root of 5. I wrote this one intentionally, so which is 12 minus 4 square root of 5 all over. Now, as I said, it was a difference of 2 squares where the center subtracts. This and this will cancel out. So what you have is 9. Now square root times square root is the number itself. Square root of 5 times square root of 5 is 5. You see, you have rationalized, you have removed what? You have removed that square root at the bottom. That's what it means by rationalization. So it will be 12 minus 4 root 5 all over 9 minus 5 is 4. Does it end here? You can end here, but you can continue, because if your calculator like this, it won't give you the answer. Why? Because 12 minus 4 root 5. Here you can see that 12 can be written like this. It's 4 times 3 is 12. You see, if you still remember, we got it from here, 4 times 3. Alright, so it's minus 4 root 5 over 4. Do you see that 4 is common? You can factorize 4. When you take out 4 here, 3 will remain, minus square root of 5, and then all over what? All over 4. You see that? That's where now the 4 cancels, and the final answer become what? 3 minus square root of 5. Can you believe that? So if you take this question, and now let's use the calculator to check what is 4 over 3 minus root 5 equal to, see, 3 plus root 5. There it is. There, 3. It says 3 plus. Why did I say minus? There is the error. I see this. It says 3 plus. You see the importance of checking with the calculator? It says 3 plus. I had a plus here, but I wrote minus. I hope you picked that. So this was supposed to be plus all along. This was supposed to be a plus, not a minus. So see that, because there was a plus on top. And then even here, it's supposed to be a what? A plus. So continue at the top. This is supposed to be a plus. It's supposed to be a plus. Then the final answer, we can all agree that it's what? It's not 3 minus, it's actually 3 plus. You just correct that for me, and then it will become correct. Guys, as I said, we end there. Join me again in the next lesson, whereby I continue with the remaining part. But the aim is to keep on bringing you all these as you prepare for your final exams. Thank you.